Okay, hello students. So today we're going to talk about finding probabilities using tables. So far we've looked at finding probabilities using the formula for a given problem. Now we're going to look at tables and how tables can help us find probabilities. And in most cases, finding probabilities using tables are a lot friendlier. So to begin, let's go ahead and look at this very simple example right here. We want to look at what is the probability of taking the bus. And so this is very similar to what we've done in chapter 1. We're simply looking at the row or column with bus, taking that total and dividing it by the grand total. So here, we know that the probability of taking a bus to school is 55 out of 278. Okay. Now, actually going on and applying it to and events. So here we want to know what is the probability of being male and taking the bike to school. So as you remember, whenever we're dealing with and events, we're looking at the intersection of the two events. So if I have two events A and B right here, the probability of A and B happening is this shaded area right here. This is where they intersect. The same thing for when we're using tables. We want to find where the two events intersect on the table. So here, we're going to look at the column or row with male. We're going to look at the column or row with bike. Here we see that they intersect, they overlap at this number 14. So 14 becomes our numerator out of the grand total. So 14 out of 278 is the probability of being male and taking the bike. So this is saying that there are 14 males who take the bike out of the 278 students that are considered in this table. Our next example is also an and event. So what is the probability of being female and taking the car? So here, again, looking at the row or column with female, looking at the row or column with car, where they intersect, that becomes our numerator out of the total, 278. So the probability of being female and taking a car is 90 out of 278. So and events are very simple to find using tables because we are literally looking at where they intersect on the table, picking that intersection off, and just dividing it by the grand total. Now moving on to OR events. So OR events require a little bit more work, but it's still very simple compared to actually just looking at a problem and trying to find those probabilities by yourself. So if you remember, probability of OR events, so probability of event A or B happening, that's going to be probability of A plus probability of B minus their intersection. Sorry, this is really bad. My stylus is not working really well on my laptop. Okay, so we have this formula right here. And so I'm going to rewrite this in terms of the problem. So here we have probability of female or walk. That's going to be equal to probability of being female plus probability of walking minus the probability of being female and walking. So now that we have written it in this form, can we find probability of female? Can we find the probability of walking? And can we find the intersection just based off of the table? Yes, we can. So let's go ahead and do that. Probability of being female, we know is 154 out of 278. plus probability of walking. Probability of walking is 37 out of 278. Finally, subtracting their intersection. So female and walking intersect at 25. So 25 out of 278. So after solving that out, you should get a final answer of 166 out of 278. Okay, so again, like I said, finding OR events does require a little bit more work because you're finding probability of A, probability of B, and probability of A and B. But it's a lot simpler compared to being given just a word problem and trying to find those probabilities yourself. Now the next example is another OR event. So let me just write it out quickly before we look at the table. So probability of male or car, that's going to be equal to P of male or car, that's equal to probability of being male plus probability of taking a car minus their intersection. So probability of being male and taking car. Back to our table. Probability of being male is 124 out of 278. Plus probability of taking a car. That's 165 out of 278. Minus their intersection. So male and car intersect at 75 out of 278. Okay, so after you solve that through, your final answer should be 214 out of 278. Okay. So now, moving on to our next example. What is the probability of taking a car and walking? So here we have an and problem, so we're going to look at where they intersect on the table. So here, car is in this column, walking is also in this column. Based off of this table, they don't intersect anywhere. And so what does this tell us? So does it make sense for someone to be taking a car and walking at the same time? No. And so in this case right here, we're dealing with a mutually exclusive event. And as you recall, mutually exclusive just means that the two events cannot occur at the same time. And from the PowerPoint, we know that if two events are mutually exclusive, then P of A and B is going to be 0. So in this case, probability of taking a car and walking, that's just going to be 0. That's because they cannot intersect, they cannot happen at the same time. Finally, our last question. So given a table, can you construct a Venn diagram for male and walking? So I'm going to go ahead and create 2 circles to indicate my 2 events. So here, I'm going to call my left circle the event male, and I'm going to call the right circle the event walking. So what we want to do is construct a Venn diagram and be able to fill in the frequencies for each of these parts. The reason why I only have 2 circles is because I only have 2 events. If you have 3 events, you'll be using 3 circles. If you have 4 events, you'll be using 4 circles. So here, as I've mentioned, this middle part right here is where the 2 events intersect. And based off of this table, we know that they intersect at the number 12. And so we know that there are 12 males, or 12 people who are male and who also walk. And so this frequency in the center right here should be 12. We know that there are a total of 124 males, and so the circle over here should total out to be 124. But out of those 124, 12 of them are walking, which means that 112 are left taking some other source of transportation. For walking, there are 37 total people who are walking. 12 of them are male, which means that the remaining 25 are not male. And so here we've constructed a Venn diagram for the two events, male and walking. They intersect with a frequency of 12, which means that there are 112 males who take another source of transportation, and there are 25 female who walk out of the 37.